the borrowing rate that your client faces is 9%. Assumes that the standard pool 500 index has an expected return of 15%, a standard deviation of 25%. And assumes also that the risk rate is equal to 5%. And your fund has the parameters given in the problem 21. So this means in the 21 you have, let's look at the 21, I can also write on the left, on the whiteboard. So you have a portfolio with a expected return 11%, standard deviation 15%, risk-free rate equal to 5%. Okay, just look at this number here, sorry, forget about the last. Okay, standard poor index, expected return 13%, standard deviation 25%, risk-free rate equal to 5%. So the question now is the following. The question is, what is the range of risk aversion for which a client will neither borrow nor lend, that is, for which epsilon equal to 1? So write down these numbers here. Let me write down these numbers so that I can show you. So we have expected return of my standard poor 500 is equal to 13%, risk-free rate 5%, standard deviation is equal to 0.25%. So given this number, the question is the following. What is the range of risk aversion for which a client will neither borrow nor lend, that is, for which epsilon is equal to 1? So if you remember epsilon equal to 1, if you remember the slides, this means that if I borrow the money, so if this is my P, epsilon must be higher than 1. So if I don't borrow the money, my epsilon must be minus equal to 1. So let's say what is going to be your risk aversion if epsilon is equal to 1? Risk aversion is your A. Okay? I give you 2 minutes to solve that this exercise. Very simple. Okay, give you 2 minutes, have a look at this, the information are there. So I can also drop it here and have a look at the problem. So I want to know A. So this means that minus the 1 is lender, I give the 1 it's borrow. So I want to know his range. And I want to know how much must be the range of my risk aversion. So I want to know the range. Simple. What's the range? So I want to know basically what's the range of my A if epsilon. When I'm like this, I'm in the point B. If I'm not, do this stupid question. If I landing, epsilon must be minus than 1. We saw before because we are in the point B. Epsilon higher than 1, and remember the example before that it was 1.4, was we were borrowing the money. So how much is A? Do you know the solution? So anyone? 0 point? For what? How do you get to 0.56? This is the solution. So basically, I know my epsilon. So do you remember this is the quantity that I have to invest? This is what we end with. This is how we finish our class. So epsilon gives me the quantity that should invest in the risky assets to maximize to get the highest utility function possible. So if I'm lending, this means that no borrowing, epsilon must be minus than 1. So then simple. This is the the equation that gives me the quantity epsilon. I want to know A, I just put A here, so this is what I get. A must be higher than 1.28 for having epsilon minus the 1, so for lambda. My A, in this case, if epsilon is higher than 1, if you remember, if you check back the slides, the investor is a borrower, so A must be small enough. So again, I sort out my equation, bring these guys here. So it is A minus of this quantity, so A must be 0.64. And this is also logical. If you think about borrowing, when I borrow the money, I reduce my Sharpe ratio. So this means that I reduce my the inclination of the adjusted return for risk for my investment is lower. So this means that eventually my coefficient is going to be lower. This means less risk aversion. When I'm instead in the case of lending, not borrowing the money, so this means that I have enough equity, cash, to invest in a risky portfolio, so epsilon is minus the 1, then of course A is higher. A is higher, we said before, means more risk aversion. Okay? Do you have any questions? Yes?
Why you can't just equate epsilon with 1?
No, because yes, in the exam you can also, yes, for 1, yes, you can put 1, but what the exercise wanted to say at the end is, if you are not, you want to know the margin, how much should be A, if you don't want to borrow, so just lending or using your money, or if you just want to borrow the money. So the exercises the question wanted to ask you to get the A for both the type of investment. No borrowing the money, so epsilon should be less than 1, or in the case of you borrowing the money, so epsilon higher than 1. So when epsilon is equal to 1, it was confusing in the question, means that you invest all your money in the risky portfolio, so not risky asset, and you have the money. Okay, so here there are some other exercises that you can do at home. I will give you the solution. So let's keep on. So here, as you remember, this is the epsilon. So if you go back to the slides 18, you will get the epsilon higher less than 1. So you do not go. Okay, capital market line. In this case, before we were speaking about capital allocation line, capital market line, again, we are referring to the passive strategies. And if you remember from this morning, we said that the passive strategies are strategies that replicate a stock market index. So, this means no analysis of the securities, and of course, you can add the risky asset, for example. You can, yes, as a risky asset investment, you can invest the money in a fund that replicates, for example, the standard & Poor's. So this means that when we speak about capital allocated market line, we have combination of, for example, risk-free rate can be treasury bills and a stock market index. So in this case, the risky portfolio is a very well diversified market index. So why, here we said with the passive strategies, I can invest the money in the market portfolio. So in a portfolio that replicates a stock index. What's the advantages of investing the money in a very well diversified, so what's the advantage of having a well diversified portfolio? Of course, through the diversification of my portfolio, I can reduce the risk profile of my portfolio. portfolio. I have two types of risk. The firm-specific risk can be diversified, and this is not systematic. So more, as I can see, more I increase the number, this is N, the number of the stock in my portfolio, more the unit risk, so the firm-specific risk is going to be reduced. What I cannot diversify is the market risk, a risk that is not specific to a single security, but is common to all the security that I hold in my portfolio. An example of micro-factors, so individual risk, firm-specific characteristics, R&D, firm's R&D profile, macroeconomic factors can be inflation rate, interest rate, business cycle. These affect not a single company, but more than one. So going back to the definition, so just to give you an idea of the power of the diversification. So here we have, when we think about diversification, we have two types of diversification, two different effects of diversification. One is given by, as I said, the increase of the number of the stock in my portfolio. So supposed to have a portfolio with N securities. So as I have this portfolio where I invest the same amount and in each security I. So this is the variance of my portfolio that we saw before. This is a generic formula where I have n variance component. So this is specific to each security, and here I have a covariance component where if I have n stock, I will have n multiply n minus 1 covariance. So 50, if I have 50 stock, how many variance should I have? Eh? 50 stock. How many variance? This is specific to each firm. This means each stock. So how many do I have of these? Eh? So I have 50 stock, 50. And this is specific to each firm. So this means that each firm should have their own variance. So I should have the volatility of the stock price of the price of each stock. So if these are 50, how many components, how many variants should I have here? Eh? No, guys. So this is specific, so this means that I have, so there is a portfolio. In the portfolio there is only me, Caroline and Lina, Caroline and Marta. My name is Marta. So 3 stock. So I have a price. My price can change. So I have my own volatility, my own risk that is specific to Marta. So then there is a risk specific to you, and there is specific to Lina. So how many variants do I have in this portfolio? 3. 1 per each stock. So if n is equal to 50, I have 50 variants. 3, 3, 4, 4. The covariance, I will have n multiply n minus 1 covariance. So in this case, in our case, how many covariants do we have? Because my stock can increase or decrease because we have some common movement between the some common effect. So 1, 2, 1, 3, 2, 3. Yes, but remember, why we have 6? Because we have 3 minus, because of course there is her against me and me against her. It's the same number. So the total covariance is going to be 6, then you have to divide it, of course. Because it's 1 Marta against Caroline and then Caroline against Marta. So it's 3, multiply, 3 is minus 1 is 2, so in total 6. But then we just consider, this is why I have, in the main equation I have that 2. Okay, so here, if I have n stock, I can simple substitute these guys. This means that I can, n variants are equal, so instead of counting each variance, the quantity is always the same, so I can just multiply n for this quantity, so, and I can get the average variance of my portfolio multiply 1 divided n. This is the covariance part of my portfolio. So as n, so as I increase the quantity of stock in my portfolio, what is going to happen to these guys? If n goes to infinity, what 0? This or this? The first term, of course, if n goes to infinity, this quantity goes to 0. N goes to infinity, so this quantity, for these guys, that goes to infinity. So if I can invest this quantity, then it becomes 0. These guys here, n divided n is 1, so I have the covariance, multiply 1. Minus 1 divided n, with n that goes to infinity, equals to this quantity goes to 0. So suppose that I have a very well diversified portfolio, I can completely reduce the risk specific firm, that is this quantity here, the variance. What is I cannot diversify is the my covariance, that is these guys here, that is the market risk. Okay, so I can reduce, this is what this means, the formula we saw before. This quantity goes to 0, this quantity stays there. So of course, through the diversification number of the stock, I can get the benefit in terms of reduction of the risk. Here, very fast, because I think some of you should be already familiar with this. So, of course, if I take my simple portfolio where I have quantity epsilon invested, I have two stock, C and S. So I can write the standard deviation of my portfolio, variance, 2 multiply the covariance, so Marta against Carolina, Marta, Lina, Caroline, correlation coefficient. So the only things that here that can allow me to benefit from diversification is when the correlation coefficient is negative. Why? So here you have an example. Suppose that you have two assets. Asset C with 14% of expected return, standard deviation 6%. Asset S, expected return 8%, standard deviation 3%. So suppose that in this case we have perfect correlation. This means rho equal to 1. So if you change rho in this equation, what you get? You get that of course you get here you get different, as you can see, standard deviation. Just substitute the number. The expected return change because of course this is what the payoff that you get for different quantity invested. This is just random, just an example. So 0.2 invested. This is the expected return and standard deviation that you get. So basically you should get a combination. Your portfolio can be a combination between S and C depending on how much you invest in the two assets. When C is equal to 0, you are here. And then you move in this line. So we don't have any benefits in terms of diversification. We can see simply, if we look at the case, this one with rho minus the 1. With rho minus the 1, we we have, as you can see, if you look at this number here. So if you compare this number here, for example, for 0.2 with what we got before, so as you can see, when rho is -1, given the same expected return, the standard deviation is lower. Benefits of diversification. In this case, you can find the quantity that allows you to get the expected return, the standard deviation of your portfolio equal to 0. So in this case, I can get the perfect age just sorting out that equation for the quantity XC. So I can identify a quantity that allow me to have a positive expected return equal to 10%, but Z0 standard deviation. And if you compare this payoff, so the same expected return, the same standard deviation, the only variable that you change, it's rho. So as you can see, 4.2 here, expected return 11, standard deviation 4.5, here standard deviation 2.4. Again, I can also have, it's difficult to find a correlation, a perfect correlation +1, -1. So I can also have different value of rho, for example 0.5. So my frontier, so the combination of the two axes is going to be curvilinear. So I still get some benefit from diversification, because as you can see here, as you can see, if I move here, I can, if I'm here, given the same risk, I can get a very higher expected return. So there is a benefit in terms of risk reduction, not as in the case, of course, of standard deviation, correlation coefficient minus the 1. Here, I'm able really to find something, 0 standard deviation, 0 risk, higher performance. So, at the end, I can, there are two benefits of diversification. The one is correlation coefficient, perfectly negative correlation coefficient hedging, or number of stock. More I increase the number of stock in my portfolio, more I'm going to get the benefits in terms of diversification, and we showed before. So we stop here. The next time we will finish this part here very quickly, so that this is the part that some of you should have done in stock market introduction to portfolio. Bring silence. One second. Bring your computer for the analysis, because I will finish this in half an hour.